Okay. So this system of two equations, we're going to want to solve it by elimination and sketch the graph. Okay. So I'm going to start with a solution by elimination. Since everybody had a pretty good graph. So we have two x plus 6y equals 18 and 4x minus 2y equals 8. Now this is equation 1 and this is equation 2. So which variable do we want to eliminate? Well, it's pretty easy either way. If we multiply this equation by -2, then we'd have -4x, which would add to this 4x and eliminate x. Okay. We don't want to multiply by a negative. We can simply multiply this equation by 3, which would give us a -6y here and eliminate y. Okay. So I don't feel like getting confused with negative signs right now. I don't want too many negative signs in my equations. So I'm going to choose to write equation 1. And then I'm going to do 3 times equation 2, which will give me 12x minus 6y equals 24. Now, these equations match up in the sense that the -6y and the 6y add up to 0. So if I add these two equations, I'm going to eliminate y. If I eliminate one of the variables, I'm going to be able to solve for the other. So we end up with 14x equals 42. So that x equals 3. And I skip this step. I'll put an ellipsis in there, a couple of ellipses. Okay. Because you know how to get from here to here. Nobody has any trouble with that. Okay. Now that you know that the solution occurs when x equals 3, so you take x equals 3 and you plug it back into one of the equations. I'll usually go to the first equation because it's easy to put the arrow there. And that brings you around to the equation 2x plus 6 times 3 equals 18. 3 being a solution for x. And that was x, it wasn't y. So what I just said is a complete fabrication. So I put my arrow in the wrong place. It's x that we're going to substitute. X into which we're going to substitute 3. Okay, so we substitute the 3 for x and you get 2 times 3 plus 6y equals 18. That's 6 plus 6y equals 18. ... You're going to get y equals 2. Okay. Subtract 6 on both sides, you get 12 there. Divide by 6, you get 2. Whether you see that in your head or not, you can easily fill that in. Once you get to this stage, you're home free. Okay. If you've done everything correctly. So the solution x equals 3 and y equals 2. Now, I was going to also ask you to graph this. Okay. Now for the equation, I'll write this kind of small, 2x plus 6y equals 18. X-intercept happens when y equals 0. You get 2x equals 18, x equals 9. So that after 100 years of doing this, I still tend to write things backwards, as I just did. Okay, we have then for the x-intercept, y is 0, and it turns out then that x has to be 9. If I plug 9 in here, I get 18. Plug 0 in here, I get 0. 18 and 0 gives me 18. Well, that's simple. Then we have 4x. Well, actually, then we want the y-intercept. The y-intercept x equals 0. So we've got y equals 18, y equals 3. The y-intercept would be 0, 3. On the graph, then we have the point 9, 0. Got to go all the way up. Well, I don't have to. Again, reading it backwards, I'm sorry. So we need to go up maybe a little further here, because 9 is kind of a big number. Here's where x equals 9. Now we scaled the x-axis. So we would say this is x equals 9, and everything else has to be consistent with that. So here's the x-intercept. And then the y-intercept is 0, 3. Well, I'll put that about here. That's in the line y equals 3. Now I can attempt to sketch that straight line. Didn't quite make it, but not bad. Okay, well, I'm not going to work through the details in this one, but we can see if y equals 0, then 4x equals 8, so x equals 2. Okay, so if 9 is here, somebody's knocking at my door. Come in. Thank you. Let's start calling. Well, not going to mention your name because we're recording. If the door's ajar like that, it just means somebody's playing a video over there that's a little loud, and I don't particularly like the guy's voice. Okay. No offense to him. He might not like mine either. But you're welcome to just walk into their class. And if you forget to close the door and the guy's not talking, that's fine. If he is talking, I'll walk over and close the door. It won't hurt me. Okay. Okay, so anyhow, back to here. If y is 0, x, 4x equals 8, so x equals 2. That means the x-intercept is at 2. 9 is here. Well, that would be like 4.5, so that might be 4. I'm going to say x equals 2 about here. And I think I'm a little too far to the right. 1, 2, 3 of those only make 6. So x equals 2 should be a little further to the left, but this is a hand sketch graph. And I don't want to be too accurate because I want to demonstrate that it doesn't always work out exactly if you do a hand sketch graph. Okay, so anyhow, that's going to be the x-intercept here. And the y-intercept is when x equals 0. And negative 2y equals 8 gives us y equals negative 4. Now, y equals 3 up here. then -4 will be a little bit lower than that. Well, to say this is a line y equals -4. There's your y-intercept. And then we sketch a line through these points. And then here's our point of intersection. Now on my scale, where x is 9 out here, that looks like about y equals 4. But if x equals 2 here, that looks kind of like y equals, I'm sorry. If x is 9 here, then the x coordinate at this point would be probably around 4. But of course, if this is x equals 2, then this looks more like 3. Okay? So I'm not sure what coordinates to put on that. It's not 3 because 1, 2 of those almost makes 9. Okay? You understand what I'm saying? Now, I already commented that my x equals 2 should have been a little further to the left. So the line should have been a little steeper and the intercept would have been back this way a little further. But I'm going to say that x equals about 4 there. And what is y equal? Y equals 3 there. I'm going to say this line is y equals 2.5. This line is x equals 4. So that this point would be 4, 2.5. Now, is that consistent with our equation? Well, yeah, 4 is pretty close to 3, and 2.5 is pretty close to 2, right? So this is consistent. You can't expect, especially if your solution to the system is fractional, you can't expect your graph to show you the exact fraction. Even if it's whole numbers, you can be off. Okay, I was off because I put x equals 2 part of this side. Okay, but still, if I make reasonable estimates of where x equals 2 and x equals 9 are, and where y equals 3 is, and where y equals -4 is, and my -4, it looks like it's kind of okay. Maybe should have been a little lower, which would have moved the intersection point back this way a little bit. Okay, a reasonable sketch of your graph should confirm your solution, or should make your solution plausible. If my solution was x equals 7, y equals -2, I'd have messed up something in my arithmetic up here, I'd say something's wrong. Either my graph's wrong or my solution's wrong. Right now, I say the solution and the graph are reasonably consistent. Okay, so down here, I'll draw my final conclusion. And the solution of the graph are reasonably consistent, so we tend to believe our solution. Now, if we really want to confirm our solution, we plug 3 and 2 back into both equations. Okay, now I'm not going to write this one out because you know to do that, but if x equals 3, then 4x is 12. If y equals 2, then 2y is 4, and 12 minus 4 is 8. Okay, comes out real easily. If x is 3 and y is 2, we have 2 times 3, which is 6, and 6 times 2, which is 12. 6 and 12 adds up to 18. And now we are very confident we have a good solution. Okay? kind of triple check. Again, a graph, unless it's contrived to give you integer solutions, and unless somebody gives you a grid, and you can't walk around all your life with a grid in your hands. Okay. Then you kind of stuck with a reasonable sketch. Okay. And we've done a lot of sketching, so make sure that you do that. One thing I noticed on homework is and just in general, in the pre-calculus course, and that's also true for my physics students, I don't see a lot of sketches. Okay. I think people are uncomfortable sketching things because all the things that they've ever sketched, they've copied from a graphing calculator instead of getting their hands on it and sketching and understanding what the coordinate system is telling you. Okay, so we want to kind of emphasize this thing about sketching. Make sure you're doing good sketches. And don't rely on the graphing calculator, although it's a great tool for checking once you've analyzed something and sketched it. Let the graphing calculator tell you whether you're right or wrong. But don't rely on the graphing calculator to get the right sketch. The other thing about the graphing calculator is, ultimately, if you're in a hurry, you're going to be using a graphing calculator. Okay. If you know how to do these sketches, you're going to understand what you're seeing on the graphing calculator screen much better, and you're going to have a much better idea of what window to use for what function. So you can, if you can do this, then you can, in 15 minutes, learn to use a graphing calculator better than people who've always had one in their hands. Okay. Whereas if all you know is a graphing calculator, you're not going to be able to do the sketches and you're not going to understand what you're seeing very well anyway. Okay. So that's why I don't use graphing calculators at all in this course, but I do encourage you to use them to check your sketches. Okay, that's pretty much what you know. Need to know about a system of two variables, except that, as you know from the homework, sometimes you eliminate x and y also disappears. Okay, because this number is the same multiple of this number as this number is of this number. Okay, and if that happens, then you're going to get 0 on the left-hand side when you add the two. Okay, so you could get 0 here. X and y could both go away. And you could still get a number over here. Maybe it's 42, maybe it's 738, maybe it's something. Okay. If it's not 0, then it's false because it says 0 equals something that isn't 0. Okay. If your equation reduces down to 0 equals something that isn't 0, that means two lines are parallel. And they're not the same line. Two different lines that are parallel. Okay. And open math tells you that, and I hope you understood it. Okay, because it's pretty important. If you get 0 equals 0 here, that means that this entire equation was a multiple of this entire equation. If you're going to get the same intercepts, you're going to get the same slope. If you solve for y, you're going to get the same thing from this equation that you would from this. It's clearly not going to happen on this equation because you got a plus here and a minus here. There's no way they can be parallel. They are going to meet. But sometimes they get sneaky and you get two parallel lines. Either it's two different parallel lines if you get 0 equals something non-zero, or they're the same parallel line if you get 0 equals 0. Okay. And when I say the same parallel line, it didn't make a lot of sense, but they're the same line. And of course, same line is parallel to itself. Okay, now that does it for systems equations in two unknowns. As a mechanical procedure, everybody can learn to do this. So just make sure that you take yourself some notes. I've recommended having a section of your notebook where you give yourself little instructions. And the instruction should be, eliminate x or eliminate y. Solve for the other variable plug back into one of the equations, solve that one for the remaining variable. Then sketch a graph, usually using the intercept, but you can do it with slope at a point. That's okay too. See if your solutions are consistent, and check the solution you got by elimination, because that's the one that's going to be accurate. If these are consistent, then chances are this is right. And this could be a quick sketch. You just want to see about where the solution is. You just want to see about where they do. But if the lines clearly meet in the first quadrant and you get a solution here that puts you in the second, third, or fourth quadrant, you know, either you screwed up the graph or you screwed up the solution. Then you go from there. Okay. Now, we could also have systems equations in 3 variables. And that's what we want to look at today. Just say we got the system. Oh man, I should have made one of these up to start with. But okay, we're going to do 2x plus 3y minus 5z, make it 6z, equals -1. 4x plus 7y plus 3z equals 14. And 3x plus 6y minus 5z equals 4. Now, this is going to be equation 1. This is going to be equation 2. This is going to be equation 3. And I want to change a couple of numbers here. And we'll contrive this to have an easy solution. You can have 0 over there, that's perfectly good. Okay, so right there is a system of 3 equations and 3 unknowns. What we want to do is we want to eliminate one of the variables. Okay, so let's just look at the first 2 equations. Which variable would you choose to eliminate? Well, it would be easy to eliminate x. Just multiply the first equation by 2, and then -2, say, and then add. Okay. Well, it'd be a little bit of a pain. You'd have to multiply this equation by 7 and this one by 3, because 3 and 7 don't have any common factors. Okay. So you probably wouldn't pick on y. Okay. Although it would be easy to eliminate y between the first equation and the third equation, right? Okay. Z is all set up. You have a -6 here and a 3 here. So if you just double the second equation, add it to the first, Z is going to go away. Does that make sense? So you need to spot that. Of course, if you haven't been successful with the homework, you're going to have to think about it a little more. But we have to move on. You probably want to go back and work more on the equations, 2 equations and 2 variables, before you tackle 3 equations and 3 variables. Okay? If you're not real adept with 2 equations and 2 variables. And in the quiz, everybody did okay on the graph, although one person did something a little bizarre on the graph. And I should have commented on that. I don't want to, I'll digress later and do that. Anyhow, so that's going to be easy to eliminate. And then you can eliminate Z between this equation and this equation, couldn't you? If you triple this equation, add it to this one, Z goes away. All right. So we're going to do that. And I'm gonna ask you to write out the equations and then see what the next step is. Okay, so first we're gonna do equation one, we're not gonna mess with it. And then we're gonna do equation, well, 2 times equation 2 plus equation 1. Okay, that means we're gonna double everything in this equation, multiply both sides by 2 to make it state it more rigorously. And we're gonna add that to the first equation. That's what we're gonna write here. Okay, and then we're gonna take equation 3 and add 3 times equation 2. For equation 2 is this equation, not the one we're going to get here. Okay, because the circled numbers always refer back to the 3 equations in the previous step. All right, so if you would do that for me, write down this, this, and this. Now, the other thing is, you're probably going to want to do some calculations. I just want to see the results here. If you do the calculations somewhere else, to the right, to the left, in the margin someplace, leave yourself room for the system to develop here without a bunch of calculations, okay? So you would maybe want to write out the 2 times equation 2 plus equation 1 off to the side where you do the addition and stuff, and then take the result and put it here and so forth. Okay, so when I say circled 1 here, what I mean is we write equation 1. Okay, there's no question. We see circled 1 here, and we write out equation 1. So we have 2x plus 3y minus 6z equals 1. That goes in. Then we got to do 2 times equation 2 plus equation 1. What are we going to do? We're not going to do that here. We're going to do that over here, and then we're going to write our result. So let's see, I'm just going to do 2 times equation 2. Okay, well, we multiply all these coefficients by 2. Then we get 8x plus 14y plus 6z equals 28. And then we add equation 1. And we just take equation 1 just the way it is. 2x plus 3y minus 6z equals -1. And we add them. So we get 2 times equation 2 plus equation 1. And that's going to give us 10x plus 17y equals 27. Okay, so we've done that over here. Put a circle around it or something so we don't confuse it with something else we write. Take this result. This result goes here. 10x plus 17y equals 27. We don't bother writing out 0z because we want to see clearly that z is gone. All right. So again, calculate this over here. Now we do the same step here. We want to write out 3 plus 3 times. No, we don't want to do the whole thing in one step. To start, we want to have equation 3 here and equation 3 times equation 2 here. And then we can add them and put the result over here. It doesn't matter whether you do your scratching to the right, to the left. Just leave yourself room in the margin to do the details of those calculations. Now, some of this is off the board, so just make sure we understand. What we've done over here is we're trying to follow this instruction. First, we write equation 1 here. Then we have this instruction. We're going to break that down over here. We're not going to do it down here because it clutters things up. We do 2 times equation 2 here, and then we do equation 1 here, and then we add them, just like it says. We get the result, and then we write the result here. And then we're going to do the same thing with this instruction, 3 plus 3 times equation 2. We're going to write equation 3, 3 times equation 2, and add them, and z is going to go away again. Again, we do this stuff somewhere besides here. We want a nice column. And you're going to see toward the end of this week or the beginning of next week why we want to have it lined up like that. Okay, so let me clarify what we're doing here. Okay. Equation 3 is 3x plus 6y minus 9z. Following this instruction here, okay, following this instruction, we write down equation 3, which is 3x plus 6y minus 9z equals 0. And then we multiply equation 2 by 3, meaning we multiply both sides of equation 2 by 3. That's going to give us a 12 here, a 21 here, a 9 here, and a 42 there. 3 times 4 is 12, so we have 12x. 3 times 7 is 21, so we have 21y. 3 times 3 is 9, so we have 9z. And 3 times 14 is 42. Now we add these 2 equations. Once we've added them, we take what we get there and write it down over here. Okay, so we add these 2 equations. We're going to get 15x. 6y and 21y is going to give us 27y. Our z's add up to 0, so we don't have to write that. And 0 and 42 is 42. So now we have 15x plus 27y equals 42. Now, what you have here is 2 equations and 2 unknowns. You can eliminate x or you can eliminate y and solve for the other variable as we did previously. Okay, so I'm going to rewrite this system. Now you've got 2 equations and 2 variables. I'm going to write equation 1, equation 2. Now equation 1 is the new equation 1. So my numbering up here doesn't apply down here. It might be confusing, so I'm going to actually keep it as unconfusing as possible. I'll say equation 2 and equation 3, so we're still referring back to these 3 equations, 1, 2, 3. I take the 2 equations that have eliminated the same variable and write them down. Okay. Now I'm going to solve this system for you because you should know how to solve it. So I put an underline here. So there's my system. Notice, I see where this system is, I see where this system is, and now I see this system with two equations. I can spot them easily. I've got things arranged so that I can easily see what I've done before, so I can easily see how this whole thing is progressing. I'll put a little arrow there. This, what's in this box now comes down here. Okay. What's the next thing I want to do? Well, I can either eliminate X or Y. Okay, well, 17 and 27 don't have any common factors. So if I'm trying to eliminate Y, I'm probably going to multiply one of these things by, well, the first one by like negative 27 and the second by 17. Then we're going to get big numbers that I don't want to have to deal with unless I really need to. Okay, it would work. You just have to write down bigger numbers. You have to use your calculator for multiplication. You wouldn't have to, but you probably go ahead and do that. Okay. But what I'm going to do is I'm going to say, well, 10 and 15. I should immediately see that 15 is 1.5 times 10. And if I don't, I see that, well, this is 2 times 5, this is 3 times 5, okay? So if I multiply this by -3 and this one by 2, I'm going to match up the x's. I can just see, what's the smallest number that's a multiple of 10 and 15? Okay, that'd be 30. 3 tens is 30, 2 15s is 30. So I do -3 times the second equation and 2 times the third equation. And I get -30x minus 51y equals 81. And it's -81. Careful about that negative sign. I'm telling myself that because y'all are better at it than I am. Okay, now that's a simple step, one that you should be used to. Again, if you're at all fuzzy on 2 equations and 2 unknowns, make sure you've got that down before you tackle 3 equations and 3 unknowns. So this should be pretty obvious. And what are we going to get? X's go away, we get 3y equals 3. So y equals 1. Okay? Now, presumably you have more room in your paper than I have on the board. Don't start one of these things at the bottom of the page. You know, always try to start it where you have plenty of room to work it. Okay? But I'm going to have to fudge a little bit. So I'm going to take that y equals 1, and I'm going to plug it back into one of these equations. Okay? Well, just to abbreviate what I have here a little bit, I'm going to write out 10x plus 17y equals 27, 15x plus 27y equals 42. Be sure to copy it down correctly. Okay, so that's just my equation 2 and 3 from before. Okay, this is copied. And I can't read that, it says copy. And then I'll put some dots here, and we're going to get x equals 1. Sorry, y equals 1. What do we do with that? The same thing we just always do, plug it back into one of the equations. Doesn't have to be the first one, because I'm going to use little arrows to show what I'm doing. I'll go up to the first one. And that's going to bring us down here to the equation 10x plus 17y, but that's 17 times 1. Okay. And we solve that. And we get x equals 1. Of course, we're gonna have 17 here, subtract 17 from both sides, we get 10. 10x equals 10, x equals 1. If you don't understand how I got from here to here, just do it yourself. Write this equation down, don't look at anything else and solve it. Because you're gonna do that easily. Everybody is very good with this type of linear equation. Okay, well now I've got x equals 1 and y equals 1. I've got the solutions for two of my variables. Okay. And now we're going to plug these solutions into one of the original equations with three variables. Plug this stuff in one of the original equations. Which equation do you want? Tell me 1, 2, or 3. It doesn't make a bit of difference. Both. Everybody give me some number of fingers. Well, 1, 2, 1, 1, and 1 adds up to 3, so we're going to do equation 3. That's what you get for taking the easy choice. But equation 1 would have been fine. You say original equation 3. That equation's written very badly. Not sure how to rescue, but that might help a little. Okay. Well, do that for me and see what you got. Okay, well, everybody did that quickly. That was very good. Pretty easy. You got equation 3. So you get 3 times 1 plus 6 times 1 minus 9z equals 0. And you would, yeah, get 3 plus 6, that's 9. Subtract 9 from both sides, you get negative 9z equals negative 9z equals 1. Everybody got that, right? Okay. Finally, you plug those numbers into equation 2 and equation 1, make sure that they work out. In other words, if x, y, and z are all 1, then this is going to be 4 plus 7 plus 3, right? And 4 and 7 is 11 and 3 is 14. It works. Okay. And you're going to get 2, 3 minus 6. That's 5 minus 6, which is negative 1. Now I chose to write out 3 equations where the solutions were all 1. Okay. Because it was easy for me to get it right. They won't all be that nice, but you're going to see examples. The process is always the same. Okay. I can't stress enough that I really recommend that what you have on your paper is this, and that this continues to all this. Okay. So all this and all this should go flow right down your paper. Everything else off to the side. Or, don't just write down all these equations without like maybe circling the two steps that you used to get these equations. And if you got to do some side calculations on these equations, well, you really don't, because everything just kind of proceeds once you've eliminated your first variable, okay? So all this can just go right under that, right down the page. Nice and organized so you don't get confused about what to do next, okay? So you can follow every step and get used to doing this. Somehow this gives people trouble. 3 equations, 3 unknowns, people have never done very well with that, okay? So that's why I kind of stress really organize it, okay? Makes it much easier to learn. And then if you want to adapt the way you organize the solution to some way that makes sense to you, but still would make sense to somebody else, then feel free to do that, but follow this procedure with all the notations and everything so that you are sure you understand. Okay? Okay, well, very good. You all did well.